Hello MSCFT. Today's topic is Introduction to the Manufacture of Soft Drink or Manufacture of Carbonated Beverages. Over the past few years, it has been found that many microbreweries or beverage industries have an increasing interest in producing soft drinks. So, this lecture has an objective of introducing the production procedure of basic production procedure or principle of production of carbonated beverages. Now, the ingredients which are needed to produce the carbonated soft drink. First and foremost, the important ingredient or the most important ingredient of making soft drink is water. Water is the most predominant ingredient found in soft drink. The quality of water is used is very important in specifying standards for water. It is obvious that the water should have no impurities of any nature or kind to interfere with proper taste, color, physical appearance and carbonation of the product. So, the raw supply must be from an unquestionable sanitary source. Municipal water supplies will contain chlorine, which should be removed by use of a carbon purifier. The carbon purifier will also remove the unwanted color, odor and tastes. If it is necessary to remove particulate matter, that is solid material, the use of a sand filter or cartridge filter type should be used. We know the sand filter. It's a kind of basic filter which use sand to purify the water. Now, what is the cartridge type filter? Cartridge type of filters are made from spun polyester and placed inside a tank. Like the AquaGuard in our homes have cartridge filter to purify water. This system, the spun polyester, work by pushing water from the pool into the tank. The water then passes through the polyester filters and dirt gets stuck on the screen, allowing for clean water to pass by. The chlorine will kill the bacteria that find their way past. Sediment filter cartridges can be made from wound string, rigid foam or pleated film. They are most often made of a substance called polypropylene, which is resistant to the growth of bacteria. However, cellulose is also sometimes used. Now, the alkalinity of the water is of concern. High alkalinity of beverage water neutralizes the beverage acid, and the acidic flavor of the soft drink is its USP. And the high level of alkaline produces bitter taste also. So in most cases, acid levels can be adjusted to compensate for high alkalinity. But for commercial manufacturing process or high level manufacturing process, alkalinity should be removed, and it can be removed by reverse osmosis, that we know, RO system, deionization and distillation unit. Now, what is reverse osmosis? A semi-permeable membrane has small pores that block contaminants but allow water molecules to flow through. In osmosis, water becomes more concentrated as it passes through the membrane to obtain equilibrium on both sides. Reverse osmosis, however, blocks contaminants from entering and the less concentrated side of the membrane. For example, when pressure is applied to a volume of salt water during reverse osmosis, the salt is left behind and only clean water flows through. But in osmosis, the ions or molecules randomly diffuse along the concentration gradient. And what is the concentration gradient? That is higher concentration to lower concentration in order to achieve the equilibrium. So, osmosis and reverse osmosis are just opposite. Reverse osmosis uses energy and pressure to remove the contaminants through semi-permeable membrane, but in osmosis the liquid try to balance the concentration on the both side of the membrane. So reverse osmosis is the one method to remove the alkalinity as well as the impurities, mineral impurities from water. Then deionization. What is deionization? We know that when an electric field is in the middle in a box, when electric field is generated and one side that there is cathode, that is for plus charge, and another side, on the other side the anode is present, the minus charge, the molecules present in the fluid within the box, they will go to the opposite charge, whether cathode or anode. So deionized water is often synonymous with demineralized water, as we know that minerals have charges or ions, and from deionization water, almost all of the minerals from the water are removed. Cations like sodium, calcium, iron and copper, and anions like chloride and sulfate. So both type of ions or minerals are removed through deionization process. And the third is distillation process. Now what is distillation? It's a very simple process. We also have this water distillation unit in our lab, from which we produce distilled water. What does it do? The water has been boiled in a pot or a container, and then water vapor, it is converted into water vapor and it goes through funnels and condensate it, where it is condensation takes place. So water, the original or pure water, converts into water and the impurities left in the boiling section. So these units take almost everything out of water. This is not necessary for low cost plant, but for commercial level plant it is definitely necessary and mandatory. Now as we can see that this is the diagram of water treatment process using rapid coagulation. As we know, the coagulation is done with the help of lime, chlorine, and ferrous sulfate. Chlorine and ferrous sulfate acts as a coagulant. So clarified water can be collected from here, and the mixing and coagulation reaction will happen here, and raw water input is from here, and the slurry goes out from here. The coagulated slurry goes out from here, and it is the drain to clean the system. Then after coagulation, through pump, clarified water goes to the sand filter, where sand and gravels filter the water. With the help of sand and gravel, the water is filtered. Then this is the holding tank, where residue of chlorine can be approx 8 mg per liter, and then this goes to the activated charcoal tank, where removal of residual chlorine takes place. Then it can go to the filter, whether it can be deionization unit, reverse osmosis unit, or anything like that, or cartridge filter. Then UV treatment if necessary, if the water quality demands there or standards demands there, then UV treatment for disinfection of water or sterilization of water is done. And now you can see the clarified water from here. So this is the diagram for water treatment process. Now second is the typical carbonation system, that we will see later. Now water, next ingredient is sweetener. The most expensive ingredient in a soft drink is sweetener. So sweeteners can be bottlers grade cane or bottlers grade beet sugar. So for high quality drink we should use the bottler's grade sweetener. This is sucrose, as we know. Then dextrose or corn sugar should not be used, but HFCS, that is high fructose corn syrup, which is a product of corn. It is also known as glucose, fructose, isogluconase, and glucose fructose syrup. It is made from corn starch, and production of conventional corn syrup, the starch is broken down into glucose by enzymes. So directly we can't use corn sugar or dextrose, but HFCS can be used because it is in the purified form of glucose. This product can replace sucrose or can be used in combination of sucrose. Although HFCS, that is high fructose corn syrup, is less expensive in large quantities, but when purchased in less quantities, it's less cost effective. It must be stored above 85 degrees Fahrenheit to prevent solidifying. And there are types of HFCS, and it is dependent what flavor we need, and it can be used according to the standards. Now honey can also be used as flavoring and sweetening agent, but it cannot be used as wholly, but it can be used in a combination because it has a unique taste and character which it can give to soft drink. Then molasses and malt extract, these are the intermediate product of the sugar production. Molasses is the intermediate product of the cane sugar production, and malt extract is made from malt, barley malt, etc. So basically, to give interesting flavor, we can use any one sugar or combination of different sugars. Artificial sweeteners and non-nutritive sweeteners can also be used in soft drinks. There are number of diet sweeteners are available. They are generally used in combination in order to reduce cost and aftertaste and to increase shelf life, as aftertaste is the side effect of using the artificial sweetener. There are number of new products which are using numerous type of combination of sugar and artificial sweeteners. Now third ingredient is flavor. Now flavoring ingredients used in making soft drinks must be water soluble. This is mandatory because they have to dissolve in water in order to make final product, and they should completely disperse throughout the drink with no separations. Flavors are supplied for soft drinks, the carbonated soft drinks. First are extracts and second are emulsions. The flavoring oils and compounds are dissolved in alcohol and water. Normally, this form of flavor will produce a clear type of soft drink. Examples are lemon, lime, like 7-Up type, ginger ale, and cream soda. Then second emulsions using various types of food gums, flavoring oils suspended in aqueous solution. Homogenization is used to stabilize the oil in water compound. So, first extracts with those are already homogenized and they make homogeneous mixture with water, and second emulsions which need homogenization to be stabilized in the drink. Now citrus flavored drinks such as orange and grapefruit use this system of emulsion and produce a cloudy type of drink, and we know those type of drinks. The orange flavored drinks are cloudy type of drink, they are not clear drinks. The source of flavor ingredients can be either natural or artificials. Natural flavors are derived from natural sources like fruits, roots, bark, berries, etc. and artificial flavors are made in the lab. The chemical flavor or chemicals that have identical flavors to the natural fruits, roots, bark, berries, etc. So now these artificial flavors are compounds such as esters, aldehyde, alcohols and acid. Artificial flavors make excellent tasting products and they are easily available, stable, safe for use and consistent in composition, cost effectiveness as well as the taste. Soft drink flavorings are specifically formulated to be used in the soft drinks. Now, next ingredient is acid. Acidulants are used in soft drinks formulation to effectively enhance the flavor, and acidic flavor is the USP of soft drinks, especially carbonated soft drinks, because the combination of carbonation and acid creates a fizz which is desirable for consumers. They are referred as flavoring acids. In some drinks, acid is used to extend the shelf life of the product. In this case, it acts as a preservative or activates the added preservatives. So, different types of acids are used, like most popular and versatile acid is citric acid. Other than citric acid, phosphoric acid, then tartaric acid from grape flavor is used. Then malic acid is also used, or in combination like sugars, ascorbic acid, citric acid, malic acid, tartaric acids are used in the combination to produce characteristic desirable flavor. Now, air or oxygen causes off taste, and ascorbic acid is used to prevent this problem. So, ascorbic acid also acts as an antioxidant which depress the oxidation process in the presence of air. Now, next ingredient is color. Many soft drinks contain added colorants. The color is added to enhance eye appeal. As we know, first we eat or take or consume the product by eyes. First consumers see the product. If it appeals his eye or her eye, then only he decide or she decide to take that drink or food. So eye appeal make the drink more psychologically desirable. Other than brown shades, most soft drinks use FD&C certified colors. That means the food grade colors. The brown colored drinks use caramel coloring to achieve their appearance. Then natural colorings are also used. It depends on the combination of the or desirable end product. The color, what is desirable, it is dependent on that. Next ingredient is preservative. Although soft drink manufacturers would like to make their products without the added preservative, they cannot do so without the threat of taste or spoilage. The most widely used and cost effective preservative is sodium benzoate, and there are other preservative available: potassium benzoate, potassium sorbate. The amount and the application is dependent on the standard. So preservatives affect the carbonation level, pH. So the preservatives are used on about vigorous trial and error combinations. What will suit the product? Now, preservatives are biostats, not biocides. What does it mean? They prevent growth of organisms, but they do not kill organisms. Biocides are killer of organisms and biostats are the preventer of growth of organisms. So, preservatives are used to extend the shelf life of the carbonated drink. Now, the sanitation, which is very much necessary to ensure the quality, appearance and full flavor of any soft drink. When equipment becomes contaminated, yeast, bacteria or mold organism begin to appear in the finished beverage. So, sanitation is a very much important aspect and any industry should comply to the standards, and in India FSSAI standards, any industry should comply FSSAI standards. Now the making of the product. Soft drink production can be accomplished using two different methods. First method is pre-mix method and second is post-mix method. Pre-mix method entails making a finished drink by combining all the ingredients in a vessel, that is water, preservative, sweetener, flavor, color and acid. Then after that carbonating. Carbonating can be done with a stone in a pressure vessel or in a keg. Now carbonating a beverage means dissolving carbon dioxide into the product based on temperature and pressure. The lower the temperature of the beverage, the lower the carbon dioxide pressure needed to achieve a given carbonation level. So, and next method is post-mix method. This procedure is similar to the pre-mix method except only part of the water is used to make a finished syrup containing all ingredients, the remainder of the carbonated water is added at the bottling production equipment or bar dispensing equipment. Post-mix allows you to make finished product using only 1/6 of the production or storage tank capacity as you would have to have when making premix. Because why there is a difference? Because in premix method the whole water is mixed in a vessel with all the ingredients. Only carbonating is done in a different vessel. But in post mix methods, water is divided, the base material or base raw ingredient is water, is divided into two parts. One for making syrup with other ingredients, and second part of water is used to make a carbonated water. So, and after that the two of them are mixed. So that's why post mix needed the lower capacity of tanks and equipments in the production unit. Now this is the table or guide for carbonating certain types of soft drinks. So these are the carbonation for carbonated water. 5% of the volume should be carbonated. Then cream soda 2.5 to 3.5% volume should be carbonated. And for lemon or lime up type 4% volume should be carbonated likewise. Then labeling should comply the FSSAI standard. This is not the FSSAI standard. I am attaching the FSSAI standard for beverages. Extract the standards for carbonated soft drinks and use those standards for making handwritten notes. Now we can see the typical carbonation system diagram. This is the static cylinder or tank, and this is the waterfall tank. So the waterfall tank is more productive than the static tank. In static tank, it is difficult to achieve efficient carbonation because in static tank syrup is there and carbon dioxide is added. So it is difficult to mix the gas and the liquid. And in waterfall tank, the syrup is descend as a waterfall. As we can see, the syrup of the product or the drink descends as a waterfall, and carbon dioxide is there in the tank, and this mixes with the carbon dioxide, it mixes with the waterfall of the soft drink, and the carbonated product is there. Now this is the product. Carbon dioxide gas bubbles are there, which produces fizz. So basically this procedure takes place from here. Product, that is soft drink, is going from here. The bubbler or bubbler is adding the carbon dioxide into the liquid product, and here we are receiving the carbonated product. So This is the typical carbonation system. Now, this is the process overview of carbonated beverage manufacture. As we can see, these are the concentrate ingredients, flavor, color, juices. These are optional. Then preservatives, salt, electrolytes, buffers, and nutritionals. These all are optional. Then sweeteners, combination of sucrose, high fructose corn syrup, medium invert sugar, blends, whatever combination of ingredients we take, sweeteners, and then the treated water. Both three of them are mixed in the syrup blending tank, and from this is the post mix process. As we can see, the half of the water is going in the syrup blending tank, where sweetener and concentrates are added up with the water, treated water, and the half of the treated water goes to mix processor or carbonator, where carbon dioxide is added. Now the syrup, from the syrup blending tank, syrup is also goes to the carbonator and then to the filler, where bottles, cans, closures, packages are there and they are filled. Then this is the finished product and the secondary packaging is done, and this goes to the warehouse. So these are the type of packaging products which are used, like PET, then paper, glass, metal, etc. Now I think it is clear the manufacturing process of soft drinks or carbonated beverages. You can prepare handwritten notes on the basis of this particular lecture, and please incorporate FSSAI standards for carbonated beverages that I am attaching the whole standards for beverage industry issued by FSSAI.